All right, welcome back again. I guess it's time to start talking about classes. So classes are, of course, extremely important in object-oriented development. I mean, they're actually more important in Objective-C because, like, all your functions have to be in a class. Whereas Swift, you could actually have functions as first-class citizens. So classes are extremely important in Objective-C. No shock on that. We're going to go ahead and make our bank account class again, same one that we did in Swift. The bank account's going to have two properties, name and balance, and it's going to have methods for deposit and withdrawal, and we're also going to make it to where you can print it this time. So the first step is to go ahead and switch over your playground to be the classes. So I'll go ahead and hop over and do that. So here's my viewController.m, comment out the last one, uncomment the final one, which is classes. If you go look at classes, the classes is very simple. It's just got a run method, and it's just kind of empty right now. This is where we're going to put the code to actually use the classes, whereas the classes themselves, we're going to have to create new files. So right now you can see that there's a folder, I guess it's technically a group, called classes. I want you to right click in here and say new file. And what we're going to do is we're going to create a new Cocoa Touch class. So make sure you're in the iOS source Cocoa Touch class. And we're just going to call it bank account. What I want you to do is I want you to set the subclass to be NSObject. You can see that mine is already set to that. And make sure that you're doing Objective-C. So we're going to create a bank account, which is a subclass of NSObject. That's the most generic type of object. And of course it's in Objective-C. Once you create a file, you can save it wherever you want. The default location is preferred, and it'll give you two files. It'll give you a .h file, which is an interface, and then you can see it's a subclass, so there's a colon in the .h file to say who the superclass is. Whenever you subclass NSObject, it brings in foundation. If you were to subclass like a viewController, it'd bring in UIKit. Usually it doesn't matter what it brings in. And then there's also a .m file with this NSObject template. You can see it's empty. If you had made a new viewController, it actually brings in a ton of template code, but NSObject is kind of the simplest thing, and it's fairly empty. So what we want to do in this interface is we want to create a couple properties. So we're going to create a property for the name, and so it's an NS string, and I'm just going to call it name. And you can see that the qualifiers that I put on my property is I want it to be non-atomic. I always want them to be non-atomic. And I chose to say copy here. Usually you would say strong, but for strings I like to use copy because it's not much overhead. It just maintains its own copy of things. And then I also want a property for the balance. There's a lot of different ways that you could do the balance. You could use an NS number. I'm going to choose to just use a double. So there's my balance. Also notice that I'm choosing to put these into the header file. As we learned about before, if you wanted, you could make another interface. So I'll just kind of do it real quick, then delete it. You could make another interface inside the .m file. The only difference being that it would have to use category style syntax and put it here. It's of course yelling at me because I can't have them in both places. But I could actually put those properties internal if I wanted. Now, it turns out that's not what I want to do. I'm just going to keep it simple. I'm just going to put them in the .h file. Because, to be honest, I'm writing this class for me to use, and I'm not worried about where they're at. So if I choose to put them in the .h, that's great. If you want to put them in the .m to keep them private, that's fine with me as well. We're also going to create our first initializer. So an init, so usually they start with the word init. That's a very much expected naming convention. And they should always return an ID. That's a little weird. Like you would expect for it to return, a bank account pointer. That's what you should expect. But they return IDs, and the reason they do that is so that when you subclass it and you want to override this method, it all works out happy. Init by itself, like there would be no reason for me to do this. That's something that you get from your superclass. So if you wanted to create an init function, you don't have to declare it in the .h. The reason we're here is because I'm going to declare a custom initializer where I will let people pass in a name and a balance. As far as the naming conventions go, I chose to say with name, with balance. But I mean, if you wanted to do that differently, you totally could. I'm also going to add the instance methods here while I'm in the the .h file, and I'm going to make one that's called deposit. It's going to receive a double for the amount. And then I'm also going to make a withdrawal method, so it's really similar to what we did in Swift, right? You'll notice that both of these methods are instance methods, so you would call these on a bank account object. All right, so there's my interface of the things that I would like to make this, this class do. Typically what I do is if I'm kind of designing the interface first, I just take those prototypes, get them on my clipboard, I do a control command up, and then I paste them into my implementation file. It of course yells at you because you need to replace the semicolons with curly braces. You also, it's going to yell at you whenever you claim to return something but you don't return anything yet. So let's go ahead and start with the initializer. So the init with name with balance. The way initializers work is they've kind of got a little bit of boilerplate code that you're asked to always use. So you're supposed to always call superinit, check to make sure self exists, and then return self. To be honest, this whole like check to see if self exists, this is unnecessary in my opinion. This is like, did the memory allocation work? I mean, if it fails, it's going to be a disaster, but this is how they recommend you always set up inits. So this little simple structure here, just go ahead and do it and it'll be fine. And then anything you want to actually set up inside of here, you know, you can actually take the name and set it, and then take the balance and set it. It just so happened that this initializer took in the parameters that it manages. But I mean, later when we do like tic-tac-toe, we'll take in no parameters and we'll set things, and you'll see how that works as well. So there's our initializer. It's pretty simple. Deposit is also going to be pretty simple. We're just going to take the amount and add it to the balance. And then withdraw, we're going to do the very same thing, except for we're going to subtract the amount. So that's enough to get going. Later we'll come back and add a description to this guy so that we could use it for printing. All right, so now we've got a class ready. Now we need to actually go use it. So we're going to hop over to our classes.m file, and we're going to make a couple accounts. Before we can use anything, though, we do have to import it. Swift has done a lot to where you don't have to do the imports, but Objective-C very much requires you to do imports whenever you're going to use some other class. So that you should probably expect. So I'm just going to go ahead and create an account. I'll call it Dave account. And then I'm going to say bank account, alloc, and then I'm going to use my special initializer, init with name with balance. I'll just make the name be Dave, and I'll give Dave $100. Sounds like a good plan. So right now there is no descriptor method on it. So if I wanted to print out Dave account, I would actually have to print it out kind of piece by piece. So I could say like name, percent at, and then balance. And I guess I could put it in like a $sign and a %.2f if I kind of wanted to make it look good. And I could just say Dave account dot name, and then Dave account dot balance. And since those were in the .h file, that will actually work out just fine that I can use those. So here I've got Dave account, name Dave, balance 100. And then if you wanted to, you could call your two methods on it. So you can say Dave account, deposit. So if I wanted to deposit $50. By the way, the compiler is really good, so I forgot my opening bracket, but I can actually just type it at the end, and it'll figure out where the one at the beginning should have gone. And then I could print them again. And then I should probably go ahead and withdraw something. So I'll just say withdraw. I'll withdraw $10. Sounds good. And then I'll print him there. So if I run it now, it should say that I started with 100, then I'm up to 150, then I'm down to 140. Another way you could print it, by the way, is you could actually like take this like formatted string here and move it into the class. And so if I move it into the class, I could just print out, you know, Dave account, and that would be a lot more elegant. And then also, if I just print out Dave account, if I wanted, I could actually take those instance variables and move them into the class and make them private as well. So the way you make this work is pretty simple. We just go ahead and override that description. So if you start typing description, description needs to return an NS string. And as soon as you type like the D and the E, you should see it should pop right up. So we're actually overriding this method, which is kind of neat. And what I want to do is I want to return, I'm just going to do an ns string with format, and I've kind of stolen part of what I want this format to be right here. So I want the format to be name, and then the balance, and then I just want to put in self.name, and then self.balance. And so now I'm kind of doing the formatted printing inside the class using description. You do not have to claim that you're implementing the protocol printable. That's something that they introduced with Swift, and you don't have to worry about it in Objective-C. So you can see that I say Dave account, and it just says name and balance, just exactly like you would expect. So description is really handy when you want to print out your custom class. All right, so that's kind of the basics of classes. They're pretty straightforward. I actually find like the classes pretty easy to use, and hopefully you do as well. Come back next time. We'll make a subclass called ATM Bank Account. See you then.